Page 228, continuing lesson 4.6. Number 4, Dylan says 4b and negative 2b are not like terms because 4b is positive and negative 2b is negative. Is he correct? And explain. So for that one, we've talked a little bit that you guys probably know. He is not correct. Since those letters are the same, since they're both B's, then those are actually like terms. And number 5, Joel spent $28 for an internet data service and pays $14.50 per month. He spent $24.50 to join an online movie streaming site and pays $13.25 per month. So write an expression to represent Joel's total costs for both memberships after M months. One thing on this, they were a little bit vague. This $28, we're going to make that assuming that that is just like a connection fee or something when they're setting up this internet for us. Okay, so we're going to assume that's just a one-time fee for us. There's different ways you can do this. If you want to actually write out an expression first, you can do that. So, for that first one, it'd be 28 plus 1450M. And then the second one, so it'd be plus 2450 plus 1325M. And then you can combine like terms. Another option you have is just to combine the kind of initial fees together. Initial fees, installation fees, joining fees, whatever we want to call them. Okay, and then we can combine the monthly fees together, which is really what we're going to do anyway, whichever way we do this. Okay, so these are monthly fees, and then the other ones are just kind of one-time fees. And so we've got altogether $27.75 a month, so $27.75M plus $52.50. Continuing lesson 4.6 on writing expressions and combining like terms, basically. If we look at workbook page 55, looking at number 1, so they want us to add these expressions. The first thing they did on number 1, they went ahead and got their like terms next to each other. So if you'll notice, you've got a Z term and another Z term. They put those right next to each other. And then the constants, they put those next to each other. And then we can combine. So 3Z plus 7Z would be 10Z. 1 plus 5 is 6. So 10Z plus 6. Those are not like terms. That would be our answer for number 1. We'll look at number 2. Similar picture here. So they went ahead and got their X terms next to each other. This one you might want to add the opposite on. We need to see that as like a negative 4 plus a negative 7. This X, we can put a 1 in front of that. 10X plus 1X would be 11X. And then negative 4 plus negative 7 would be negative 11. So 11X plus negative 11 or 11X minus 11 would be the same thing. If we go to number 5, they want us to find this sum. So again, anytime they're subtracting, if you want to add the opposite there on those. If you'd like to put your like terms right next to each other like the book did, that's fine. As far as I'm concerned, you don't have to do that. But again, if you find it helpful, please do that. So the m's, we can combine. They already have the same denominator, so that makes things easier for us. So that would be 5/7 m. Other variables, we have n's. So 4 plus -2 would be a positive 2n. And then the constants, we've got -3 plus 6, which would be a positive 3. So 5/7 m plus 2n plus 3 should be our final answer for that problem. If you wrote these in a different order, that would be fine. In other words, like if you had 5/7 m plus 3 plus 2n. Okay, any order as long as the signs and the numbers are correct. Like I said before, just generally they'll put the variables first in alphabetical order and then the constants after that. But at this point, it's not a big deal if they're in a different order. So look at number 6. Similar idea here. Again, I'm just going to go ahead and start with the variables. Nothing's being subtracted, so that makes things a little simpler. So 4x plus 6x would be 10x. And then these, I would probably recommend working that out. Remember, when you add or subtract decimals, decimals have to be lined up. So 3.2 is like 3.20. Add a 0 on the end there if you want. And that's 21 45/100ths. So 10x plus 21 45/100ths would be our final answer, or 21 45/100ths plus 10x if you want. Number 7, they want us to find the sum. So start with our a's here. 6a plus 2a would be 8a. Then we've got an x term here, if you want to put that next, plus 3x. Then we've got constants. The -2, you may want to add the opposite there. 6 plus 4 is 10, plus -2 would be 8. So 8a plus 3x plus 8, or if you had that in a different order for number 7. Look at number 8. If you want to add the opposite here, you can. We're going to combine like terms. I'm going to start alphabetically. So with the c's, 4c plus 3c is 7c. And then I've got a y here, so plus 6y. And then I've got a z, so minus 2z or plus -2z. And then we've got our constants. So -3 plus 7 would be a positive 4. So that, or a different order, or like I said, if you had plus -2z instead of minus 2z would be fine. So we go to number 9. Width of a rectangle in feet is represented by 3x minus 1.5. Length is 1.25x plus 3. Find the perimeter of the rectangle. So what you can do first, if you want to, you could kind of draw out a rectangle so we can visualize what's happening. There's our width. Width usually is the smaller dimension, and length is usually the longer dimension. And perimeter, remember, is the distance all the way around. We know on a rectangle that the opposite sides are the same length, so if you want to, you can put a 3x minus 1.5 here. You can put a 1.25x plus 3 up here. And then it's up to you how you want to do this next part. So one option is that you can write them all out. So you could write 3x minus 1.5 plus 3x minus 1.5 plus 1.25x plus 3 plus 1.25x plus 3. Another option would be thinking about that we have 2 of these widths and we have 2 of these lengths. So in other words, a common formula with perimeter is 2 lengths plus 2 widths. A third option you have is that if you add the length and width together, you could add the length and width together and then multiply that by 2. Okay, visualizing this is this L shape and this is this L shape, that's going to be the same. So if you add the length and width and then you double it, that's going to be your whole perimeter. Okay, so different options. I usually just do this one, but whatever you are most comfortable with. Okay, if you don't want to mess with distributing, if you want to just list them all out as separate things, that's fine. So if we distribute here, if you want to add the opposite on that, you can. So 2 times 3x plus 2 times negative 1.5 plus 2 times 1.25x plus 2 times 3. And then that'd be 6x plus negative 3 plus 2.5x or 2.50x plus 6. So at this point we are ready to do some combining. So if we want to combine our x's together, 6x plus 2.5x would be 8.5x. And again, if you were working that out, remember 6 is like 6 0.0. So decimals have to be lined up when you add or subtract. And then we have some constants we can combine. So negative 3 plus 6, which would be a positive 3. So this would be our perimeter for the rectangle. Number 11, Maria has a fence around her triangular garden. Very unique. First side is y plus 4 feet long. Second side is 2 feet longer than the first side. And the third side is 3 feet less than 2 times the first side. Write a simplified expression to represent the perimeter of the garden. Okay, so the 3 sides here, the first one, they were pretty straightforward. They just told us it's y plus 4. The rest of it, it's kind of a riddle, where we have to think about it. So if our second side is 2 feet longer than the first side was y plus 4. 2 more than that would be y plus 6, or if you'd like, you can put y plus 4 plus 2. Same thing as y plus 6, either way. Okay, the third side, 3 feet less than 2 times the first side. So with that, we have to think about on this one is we're comparing the third side to the first side. The first side is y plus 4. So 3 feet less than 2 times the first side. So 2 times the first side would be 2 times the quantity y plus 4. And then we went 3 feet less than that. And then for perimeter, then we would be adding our 3 sides together. So we've got some major simplifying that we're going to be doing here. The first thing you'd want to do is to distribute. So we'll just bring everything else down. 2 times y is 2y. 2 times 4 is 8. You might want to do a step in between there, you know, showing the 2 times y and the 2 times 4, or at least doing it over to the side if you don't want to rewrite all of that stuff for that purpose. And then anytime we have a y here, if you want to put a 1 in front of those, and then we can combine our y's together. So we combine those together, that would be 4y. And then we got some constants we're going to combine. So 4, 4, 2, 8, and negative 3. Add the opposite there if you need to. So 4 plus 4 is 8, plus 2 is 10, plus 8 is 18. 18 plus -3. At that point, they're working against each other now, so way more positives by 15. So 4y plus 15 would be our simplified perimeter expression. Look at number 14. Grocery store conducted a survey to determine which type of fruit its customers prefer. A table indicates the number of customers who prefer each type of fruit. So part A, they want us to write an expression for each type of fruit if n customers were surveyed. So altogether, n customers were surveyed. So we look at this for bananas. It says 30 more than 2/5 of the customers. So I'd probably start thinking about this first of all. 2/5 of the customers, if there were n customers surveyed, that would be 2/5 n. And then we want 30 more than that, so we would add 30. I would prefer you write it this way, 2/5 n plus 30, rather than 30 plus 2/5 n. The reason is, it doesn't matter for this problem because we're adding, but instead of more, if it said 30 less than 2/5 of the customers, you'd have to do it as 2/5 n minus 30. So if we're just always used to doing it in the same order, regardless if they're adding or subtracting, it's going to make it easier for us to get it in the right order. So with that in mind, if we look at the apples, 10 fewer than 1/5 of the customers, I'd like to think about this first, 1/5 of the customers, and that would be 1/5 n. We want 10 fewer than that, so 10 less than that means we're going to subtract 10 from the 1/5 n. And then the oranges, we have 5 more than 1/5 of the customers. So 1/5 of the customers, that would be 1/5 n. We want 5 more than that, so it would be plus 5. And part B, they want us to write a simplified expression for all of the customers who prefer either bananas or oranges. So we have to be careful here. My first instinct was to go and add all these together because that's what we've mainly been doing, but we're actually just looking at the bananas and oranges. So bananas, oranges, and then we're going to add those together. You can put parentheses around each group if you want, but we really don't need to do that. So at this point, we would be combining like terms. So 2/5 plus 1/5 would be 3/5 n, and then 30 plus 5 would be 35. So this would be our simplified expression.